Let's talk how symmetry and skew impact the relationship between the median and the mean. So here are some sketches. I pulled these off a Google image search of a left skewed distribution on the left, a symmetric distribution in the middle, and a right skewed distribution on the right. You'll notice that some call left skewed distributions negatively skewed and right skewed positively skewed. In all three cases, the mode is where the peak is. That's telling you something about where the bulk of the data is. In a symmetric distribution, the mean, the median, and the mode are all at the same place. So your average is exactly where your peak is, and then that's also where the median is because you see half the data is to the left and half is to the right. In reality, if you have a symmetric distribution, you'll see the mean and median and mode very close to each other, but there'll be a little noise, statistical noise in the data. So what's happening with the left skewed distribution? Well, if you follow my cursor, we've got these extreme values to the left. And what's happening is those values to the left are dragging the mean down further and further to the left. They're not impacting the median. The median doesn't care about extreme values. It only cares about what's in the middle, whereas the mean cares about what those values are. Similarly, with right skewed data, like we talked about with income in the last video, the extreme values to the right are dragging the mean further to the right than the median. Let's take a look at a brief little simulation in Excel to see what that looks like. So in this example, I've just got 5 observations, 5 numbers, and let's not worry about what they represent. Our goal is to see how changing some of those numbers affects the median and the mean. So right now the numbers are just 1, 2, 3, 4, 5. They're evenly spaced from each other, and you can see that the mean and the median are both 3. This is a symmetric distribution, and that suffices. What happens if I make some of the last number a little bit bigger? Notice the mean grew from 3 to 3.2, but the median didn't stay. Why does the median not care? Well, the median, notice these numbers are in order from smallest to largest. I have an odd number of figures here. So the median is what's in the middle. So when the 5 became a 6, that doesn't change the fact that the 3 is in the middle. But it does change the average because we include the 6 in the calculation of the average. What if we make it bigger? It's growing. What if we make it very big? Notice the mean becomes larger than almost all of the other observations, and we can make it absurd. Almost all the numbers are 1, 2, 3, and 4. Right? All the numbers are small except 145,000. But because that 145,000 is there, that's dragging things to the right, right? In a right scale distribution, the mean is now extremely large and really is distorted due to the presence of that one very, very large number that we might call an outlier. The median, on the other hand, as we've said, is untouched. Which do you think is a better representation of this data, of what's typical in this data? I'll give you a pause for a minute. Think about that. I would have to go with the median for myself because the mean hides the fact that almost all the numbers are small. The same thing occurs if we've got very, very small numbers. Let's make this a very small decimal. Now the mean by this small decimal is dragged to the left by 2.8. They're still kind of close, but we can use negative numbers to get something equally absurd. So what do we conclude? We conclude that if we're describing a symmetric distribution, we should use the mean, and if we're describing a skewed distribution, we should use the median. Otherwise, using the mean with a skewed distribution will be misrepresentative. Now we could use the median for the symmetric distribution, but the mean will be handy when we want to talk about how spread out that distribution is. And that's something we will discuss in the next section, 2.4. See you there.